Let's finally understand deadlocks and how to avoid them and fix them eventually. And I promise it's not going to be difficult. But in order to explain all of this code, I first need to give you a little bit of theory, which tells us that deadlocks are basically circular dependencies, as you can see on this picture. And deadlocks happen not only in databases, but they can also happen in operating systems or different kinds of environments where you have two concurrent requests running at the same time. Now, within databases, we have things called transactions. As you can see in this case, transaction A and transaction B. And what are actually transactions? Quick explanation. They look like this: begin transaction, then you do some kind of an operation, which can be on two different tables, and then you finally finish the transaction by saying commit. Now, in between begin and commit, this is the operations that we're doing. And the reason you want a transaction is to actually avoid race conditions. Race conditions are the primary goal that a transaction is trying to solve. Because while you're, for example, doing an update here and an update here, you don't want some other operation on this database to interfere and change the data while you're updating something. Now, going back to the whiteboard, we can see that transaction A is holding, or let's say locking, a specific resource. In this case, resource 1 is being locked by transaction A while it's performing a transaction. And then at the same time, transaction B is trying to request this resource. But since this resource is locked by another transaction, transaction B is blocked. So we're not talking about deadlocks yet. It's just locking and being blocked, right? Now, when does a deadlock happen? Deadlock happens when a transaction A is holding or locking a resource 1, as we saw above. At the same time, transaction B is locking or holding resource 2, right? Now, while they're holding or blocking different resources, so this is the first part, we lock different resources. At the same time, transaction A is trying to perform an operation or request on the resource 2, but it's already been blocked or locked by transaction B. And at the same time, transaction B is trying to do an operation and request something on resource 1. And as you can see, this is a circular dependency that you probably ran in your code as well, but this is simply in the database world. Now, this is very nasty, and to demonstrate that, I can show you some code. So the code would basically look like this, and I have a small project with some examples and how to basically fix this kind of an issue. And we have a transaction where we begin a transaction, and user A is trying to lock account 1. And actually, let me show you the database and what it would look like. Yeah, basically you can see that our accounts are account 1 and 2, and at the same time we have 110 bucks on each balance. So these are basically our accounts, and user A is trying to lock account 1. So this is the first update, and looking at this board, we're trying to lock the resource 1, and we are doing some kind of an operation. Let's say the transaction is taking some time. At the same time, after this operation happens, we're trying to do an update on account 2. So we're trying to request something on resource 2. Now, what the funny thing is, user B is trying to do the opposite. It's first trying to lock the user account 2, and then it attempts to update the account 1. So as you can see, this is pretty much a circular dependency. And to demonstrate that, I can run this node app. So I'm going to say node user A, and I'm going to say node user B, and I'm going to start A because A is usually going to have 15 seconds of some faked operation. So let's start this, and then we can see that the resource or account 1 is locked, and B is trying to update, but it's still blocked because it cannot access the account 1, because account 1 is still being is still within a transaction. Now what happens is we get an error saying error lock deadlock, deadlock found when trying to get lock, try restarting transaction. So the database usually has like a routine that checks for deadlocks within itself. And it's happening every 5 seconds. And if it finds a deadlock, it tries to resolve the deadlock by terminating one of the transactions. In this case, it chose transaction 1 as a victim, and transaction 2 actually succeeded and it committed. And it told us, actually try to restart the transaction. This is usually what you should try. So if I close this and we go to our folder called locking with retry, we're going to see that we have user A and user B, pretty much the same scenario. Let me just sort them. And we're going to see that after this fails, we're going to check specifically for deadlock error code, which is 1213, and we're going to try maximum 3 times. And the interesting part is that before trying, we also need to make sure that we roll back after the error happens every time. After we roll back, we now can retry it again. So let me try this. And we're going to come here and we're going to say user node A and user B. And as we can see, a deadlock is happening again, but now one of them is going to fail and retry. So as you can see, B succeeded again. A was victim, but is simply trying to do a second attempt. So attempt 2, and this time is going to succeed. The thing is, this is probably the best way to overcome deadlocks when they do happen, because no matter what you do, they will still happen, especially if you have a lot of requests happening on your database. Now, obviously 15 seconds is a lot. Usually database queries will be much faster, so you usually don't have to wait that much to retry this long. The retries are going to be usually instantaneous. Now, let's talk about some other remedies too. Well, first of all, what can the transaction do? Obviously, if one deadlock is happening, it's still fine. You can retry. But what if you're an application that's used by millions of users, something like YouTube? Well, your deadlocks are going to pile up, and then your system is going to be much slower. It can run out of memory. Your database might crash totally and explode. Obviously, you want to do something with this. So some of the ways to deal with deadlocks are quite interesting to learn, and you should remember those forever. So the first thing is try to access tables simply in order. So let's take a look at this example, transaction A and transaction B. Now they don't have a circular dependency because they're trying to take a hold or trying to lock the same resource at the same time, right? Obviously, they're not going to be able to lock them at the same time because there's still some micro nanoseconds difference. And transaction A is going to, let's say, take a lock on the resource 1 first. And what's happening next is transaction B is simply going to wait. As soon as this transaction A has locked it, has done the request on the resource 2 and finished completely, transaction B can now continue. Now, of course, there's going to be a delay because transaction B has to completely wait until transaction A is finished. But still, this is better than a deadlock where an actual database error is thrown. And to demonstrate that, I will simply show you that user A and B, we're going to see that the transaction begins for user A by locking the ID of user or the count 1. And for B, it's the same. So it's not, we don't start with 2 anymore, like we did here, but we're starting with a 1 again. So pretty much if you look at use case A and use case B, they're pretty much identical, right? In this case, there's no deadlock happening, so we're not going to get any error. Now, another way is usually trying to keep the transactions small. And this is normal suggestion when working with transactions. Don't make them huge. Try to make them small so that even if there's no deadlock, even if transaction B is waiting, it doesn't have to wait for too long. Also, there are different isolation levels in databases. So in at least SQL databases, you have different levels such as read uncommitted, read committed, repeatable read, and serializable. So let me give you a quick overview. I will actually push this code to GitHub so that you can try it yourself, but I also documented them here. So read uncommitted is the loosest. It's pretty much doesn't lock the reads. So let's say you're doing a transaction, and this is how you define an isolation level. And this is the first transaction. It's beginning and it's trying to select something from ID 1, while transaction 2 is trying to modify the balance of the ID 1. And it's not committed yet, but if the transaction 1 is trying to then select the balance from the ID 1, it's going to get 200 because it was very loose. So the isolation level is not super strict. If another transaction is modifying something at the same time, even if the first transaction has been started before that, is still going to get an overwritten result. So you get the idea, and there are different levels. Actually, read committed is the default in most databases. Repeatable read is more stricter, and serializable is simply going to throw an error if you try, if another transaction is trying to access the resources of the first transaction. Now, last but not least, explicit row locking is also an option. So going back to the code, we can see that we have another folder here called locking with for update. And I'm going to open that. So what do we have here? We have an interesting thing called for update. So we simply start a transaction as always, and we're trying to do the following. Instead of trying to acquire a lock for resource 1 or 2, we say select where ID in 1 and 2. So we take both of our resources at the same time and we say for update. For update basically locks these rows preemptively, meaning the A or B are not going to be able to interfere this throughout the whole transaction. So in the previous cases, if we lock resource 1 or 2, and then another transaction here tries to do something, then we're getting a deadlock, right? But since we declared this beforehand, this is kind of a way of the database transaction saying, hey, I need these resources beforehand. Please no one interfere with me. Then user B is not simply going to wait, just as in the case of doing a transaction in order. So they're somewhat similar, meaning you define an order and then there's no way for a deadlock to happen. The worst that can happen is simply one transaction wait for another one. Now this was it, guys. As always, smash like, give me a like and subscribe. Of course, this helps the channel. And if you liked it, obviously let me know down in the comments. And if you're interested, check my playlist on databases. I'm going to be posting some interesting videos there. And I'm going to see you in the next one, guys. Goodbye.